question number 7, and on page 111 in the chapter 5 review, you had identified number 8. So on page 110, number 7, what is vapor pressure? This is pressure that must be exerted by the vapor for the vapor and the liquid to be at equilibrium at a given temperature. And we'll talk about what that means later on. You also had the identify number 8. So over on page 111, the process of a gas changing into a liquid, that's condensation. Alright, so make a note for those two things. Alright, you can go ahead and put that away. I'm going to go ahead and talk about the background paper first, and then I'll give you your classwork and review a little bit, and then talk about getting into it with your problems for today. So I want to go ahead and talk about the background paper. So hopefully you have your background paper either on the computer screen with you, or you have it printed out in front of you, so that way you can look at it at the same time I am talking about it. So go ahead and get out this textbook. You can put away your physical science book, at least for right now. We'll talk more about it later. But we're going to go ahead and start with this one. Alright. So you want to go ahead and flip over to page 113. That's where it starts talking about the background paper. If you want to flip over to the format section on the next page, my page fell out, so that's why that's a little distressing. So on page 117 is where it's talking about it. So make a note for that. So make a note for 117. That's where the format is. So let's focus on that first with the formatting, because a lot of you have a little bit of struggles with it. Alright, I couldn't tell if you could see my mouse whenever I was moving it around. I couldn't tell, so depending on how large your screen is, it might not show up as well. In the last class period, I used a laser pointer, and that seemed to show up a little bit better. So I'll try to remember to use my laser pointer instead of my mouse as we talk about the formatting. I think that shows up just a little bit better on y'all's screen. I'm going to try that instead. Alright, so a couple of formatting things first. So you can't see me on the screen at the same time. I'm sorry, I put my screen off to the side. So my computer, I have it rigged up to the side of my table up here, my display table, but you can't see it and my screen at the same time. So I'm going to have to stand off to the side. I can't pull my computer any farther over because of the cords. It's as close as I can get. So you're going to have to stare at the screen, and I'm going to use my mouse or use the laser pointer to talk about different features. So follow along as we're talking about it. Alright, so first thing you need to know, you need to have that 1-inch margins all the way around. So looking at the top, you'll notice that there is a 1-inch margin up here. And then looking down at the bottom, you should have a 1-inch margin as well. Now you'll notice looking at this, that hey, that's larger than 1 inch. So how do you fix that? I'm going to turn on my proof setting marks. So you can see the P stands for that there's extra spaces down there. So what I can do to fix this is I can press enter till I can tell that the line jumps over onto the next page. I scroll over, I know it's okay, there's some blank spaces, don't need that. So I'll get rid of those. Okay, it disappears again. So let's check to make sure. Oh, nope, that was it. So now you can see, okay, that's 1 inch. That's the same amount. That's supposed to be on the sides all the way around, and it's supposed to be at the top. That's what tells me whenever I'm looking at your papers, hey, do they have a 1-inch margin all the way around, or is their front page cut off? Some of you are running into trouble down here. I think you were trying to put page numbers, and your page numbers were throwing off the margin. So if you don't know how to do page numbers, don't worry about it. If you know what you're doing and you can put it properly in the footer, okay, that's one thing, but don't worry about putting it in the footer if you don't know what you're doing. So that's what I did. I just clicked that footer just now. So if you have no idea what I just did, don't worry about it. It's not important. So just make sure you have your 1-inch margin on all sides. To adjust that, if you're wondering, how do I do this? You go over to page layout, you come over to margins, so you can see it up here at the top of my screen. You can barely see it, it's about to be cut off. So it's up here in the top corner for it. So margins, click on margins. I have mine set to normal, so that's 1 inch, top, bottom, left, and right. The custom margins is marked because I'm going to use that on the title page, but this is normal margins. So you can click on it because it's going to turn it around. We'll talk about how to do custom margins in a minute. We're not going to worry about it. So this is an example of the margins. So if I wrote on your page check margins, that's what I'm telling you to check. If something looks weird about it, so go ahead and go back and check over it. Obviously your second page is probably not as long as the first one, so it might only go to a half page. So I really notice the margins on this front page because that'll tell me, hey, did you make it all the way down there or not? Okay, so let's talk about the spacing right underneath the background to have this extra space. Some of you have too much extra space, so we're talking about how to fix that. The best way to fix this is I deleted those spaces. What you want to go in is you want to go into your paragraph settings. So we'll just grab all of it for right now, and then I'll go back and fix it. So you go into the paragraph settings section. You set it to single space and then 0 space after. So single space, 0 space after. Click OK. It'll jump all your words really close together. That's okay. It's going to be fine. Press enter twice. That'll give you that good clean ½ inch indent underneath it, or spacing underneath it. I'm going to go ahead and fix my indents over here. Then I can just grab the rest of it and then switch this back to my paragraph settings, double space. So that way, whoops, too far. I accidentally grabbed this one as well. So just the body. Paragraph, double spacing. There, that's how you get it to look exactly like how it looks in the book. So where you have that good, clean, just single spacing right there. That's the best way to do it. So for future papers, you're gonna have to do it this way. For this first paper, since it's a little bit unclear in how the book wants it done, I'll take it a different way. This is the way that you want to do it. What if you set your whole paper to double space? This is what this is. Where if it's double space like this, you want just one space in between it. I'm going to put that back and centered. Nope, wrong button. So that way you only have one space. Now keep in mind, if you want it like this, you have to turn off the after spacing. So again, going back into the paragraph settings, if you have any type of numbers over here, typically it starts off with 0.6. Your spaces get too large at that point, and that's what comes for some of you. I wrote check your spacing because that's a lot of awkward space. Like I know it only shows up as one spacing in your formatting tools, or your proofreading marks, but that's the reason why, is because you have an after spacing plus it's a double space. So if you turn off the after spacing, you get some gap. It's a little bit too large, so I'll let this go this time. It's only because you want to get that good ½ inch. It's slightly too large, like another 1/10 of an inch too large. So again, I'll take it this time, but for your investigation plan and your follow-up, you're gonna have to fix it. So, but for this one, since it's a little bit unclear, I'll take it. But just keep in mind, the best way to do it, I'm going to show you again. The best way to do it, put it all together, grab all of it at once, go to paragraph, go to single spacing, no after spacing over here, put it in, and then go ahead and adjust your spacing, get your 2 spaces that way, fix your indent, because remember you gotta have a ½ inch indent, and then grab the rest of your body, and then change that back to double space. That's the best way to get that cleanest change for it. So that way you get that nice clean ½ inch space in between the background and the rest of your paper. Notice the background, the heading at the top is not all caps. Your title page, it is all caps. Over here, it's not. So just be careful as you're going through that you're paying attention to those details. Make a note, it is double spaced all the way through your whole body of your paper, that you have that ½ inch indent. This is Times New Roman or Courier New. I'll take either one. Times New Roman is preferred, but Courier New is fine. Now make sure of your font size. This is 14-point font, and I've also zoomed in on this so that way you can see it as best you can on the screen. So 14 to 18-point font. Remember on the board, it's going to have to be 24 though. Remember it has to be in third person. Third person means that you can't use the words I, me, you, we, those words in your actual background paper. It has to be they, a scientist, a person, like you're talking about someone. So some of you forgot and you put in like saying I or my investigation, what I will do for my demonstration. Don't do that. So it has to be in third person. So be careful for that. Remember, you need 3 to 6 paragraphs. 2 paragraphs are about your topic. You want to focus on not just the history, maybe a little bit, but more of how does this work. So if you're talking about friction or magnetism or electric circuits, how does it work, or what's the basic of electric circuits? Because most of your classmates might not have a good idea over what it is. So you want to be able to explain it to them of, hey, this is what a magnet is, this is how it works. Not just, here's the history of magnetism, or here's the history of electric circuits, or here's the history of photosynthesis. You want to make sure that you're focusing on it, so that way whenever you actually do your demonstration, your classmates understand what happened and why you did it that way. So 2 paragraphs talking about your background, talking about mainly what it is or how it works. You can go into the history and examples in nature, that's fine, but just focus on mainly so that way your classmates will understand what are you doing and why you're doing it that way. Remember that last paragraph, you're supposed to list off 3 possible demonstrations or 3 different possible experiments you can do with your particular topic. You might have a good idea over what you're doing already, but you want to list off, here's 3 possible demonstrations or possible experiments. Don't spend a lot of time on that. Some of you went on and on and on about what you're doing. That's not yet. You're going to write me a whole other paper called the investigation plan, where you're telling me specifically what you're doing. I don't need that yet, so don't try to write 2 papers at once. This is just the background. You're going to write me the investigation plan, tell me what you're doing later, so don't worry about it. So just saying here's some basic ideas to help show capillary action, or to show, I forget some of the other people's are, I should have pulled up that list. Corrosion, different things like that. So that way, you can say here's some possible ideas, but you don't have to get super detailed yet. So if you were banking on that being the majority of your paper, don't. Don't forget it has to be 300 to 350 words. So make sure that you are following within that proper time frame. Most of you, I kind of checked and did a rough approximation. So I told you just to double check it, just to make sure, but I didn't do a full on count. So 300 to 350 words, just double check that. Alright, through this paragraph, 3rd person, Times Roman, double space, half an inch indent, 14 to 18 point font, 1 inch margins all around. Last paragraph, 3 impossible investigations. Is there anything else on this page? 1. Oh yeah, final draft has to be typed. So if you didn't type it yet today, you handwritten and you handwrote it again, it has to be typed by the final draft. So make sure that you have it completely typed by then. Okay, I think that's everything for the format for this particular section. Alright, look over on page number 15, how do you revise the first draft? This is like an in-class study over how to do it. So, one of the major things you want to look at to see, does it have unity? Do they all contribute to a single idea of the whole? So, if I wrote on your paper topic sentence, or needs a better topic sentence, that's what I'm talking about. Do all of your sentences in your paragraph, do they relate, wrong direction, do they relate to your overall idea? Or does it feel like there's random information thrown in it? Like for that last paragraph, a good topic sentence would be, a good topic sentence would be something like, here are some possible investigation a scientist or a person could use to demonstrate photosynthesis, or to demonstrate corrosion, or to demonstrate magnetism, or to demonstrate thermodynamics. So you want to say something like that. Don't say, here's 3 possible demonstrations I can do. That's first person. So it has to be in regards to what a scientist, what someone else is to say. So you could say, here are 3 possible demonstrations for my topic about diffusion, if you want to put it that way. So think of what would be a good topic sentence, and then include all of your information underneath it. So if I wrote topic sentence anywhere in your paper, that's what I'm talking about. Alright. Does it have coherence? Are the ideas organized so that the thoughts flow smoothly from beginning to end? So if I wrote you need to reorganize your information, or you need to shift and move things around, I'm talking about your organization or your coherence. Does it flow well from one point to the next, or to the next, to the next? Or does it feel like you're jumping around a little bit? So you have to look at your paper and decide, okay, am I flowing smoothly from one thought to the next? Or does it feel like I have to go back and re-talk about something again and then come back? So if you feel like you have to jump around in your paper, it doesn't have good coherence. So check that. Make sure that you've thought through everything about it and put all of your information and organize it in a way. So if I wrote on your paper you need to reorganize your information, that's what I'm talking about. Alright, does it give an overall background structure to your topic? In other words, is it clear and complete? Some of you tried to basically just fluff up the paper by restating the same thing over and over and over again. Don't do that. So that's not a clear and complete idea. So make sure that you're going through and that you're reading through your paper and thinking of, okay, do I have enough information? Not just to hit that 300 to 300 word count. Do I have enough information to where, if someone were to read my paper, they would understand over a good idea over how this topic works and what would be some good information before I do my demonstration or do my experiment. So that's what it's talking about, is the overall background and structure. Is it clear and complete? Now if you look at the next part, you'll notice it says, you can have someone read your paper, give an overall opinion. parents are a good person to do that, so your mom or your dad or your grandma or whoever. But keep in mind, they're not supposed to help you out with grammar and to make sure capitalization punctuation. It's your job to fix that there, and don't rely on them to fix it for you. But they can help you have an idea of does it have good coherence and uni. Remember, it's your job to write your paper, so don't bother them about it. So make sure you are responsible and you fix everything you can, and they're just supposed to give you a couple of guiding remarks. They're busy too, so don't bother them about it. Alright, how do you prepare your final draft about page 15? You're going to have to type it. Some of you remember from last year, you actually turned in 2 copies to me. We'll talk about how to do that and with the title page, but you have to type that out. Alright, you're going to turn it in with the grade form as well, so we'll talk about that as it gets closer. Just flip over to the title page example. It's on page 33 in this book, so I'm going to go stand back by the computer again. Alright, so with the title page, you'll notice that its format is a little bit different. I'm going to turn on my proofreading marks again. Alright, this one you'll notice there is 2-inch margin at the top, 1-inch margin on the sides, and then there is a 2-inch margin down at the bottom. So that's different from the entire rest of your paper. How to set that up if you don't know, you go into page layout, you go into margins, you go into custom margins, so custom margins, look at the bottom portion of it, click on it. You can set it to where the top part is 2 inches, bottom 2 inches, left 1 inch, right 1 inch. So you can set it up that way. So that's how I did it. And again, you want to check to make sure, okay, does it go all the way down? So a good way to check, if you delete spaces, put them back in. Oh, I'm going to have to send it that, that's going to bother me. Hang on. So you want to see, okay, right now you can tell that there's a lot of spaces. That is not a 2-inch margin. So how do I fix it? I'm going to go and get in the center. So you can check by putting space, 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 space. Oops. Okay, now it's going over onto the next page. Okay, I need to delete just a little bit. Going back, going back, going back. Okay, that page has disappeared from the bottom of my screen now. So if you press enter again, you'll notice the page comes back to where part of my information is missing. So delete it, you'll notice, okay, we're back to that 2-inch margin. That's as close as I can get to the bottom without getting pushed over onto the next page. That's how you tell if you're at the bottom of the 2-inch margin, if you're right there at that 2-inch margin. Otherwise, you're going to have awkward spacing, and I'll probably notice. You'll also notice that, hey, this is single space. Yes, it is. Your title page is single space only. So again, you want to make sure you go into your paragraph settings. You look up paragraph, the spacing, single space all throughout it. Turn off the after point, please, as well. It creates weird spacing. So for this particular title page, I'm not going to be too picky about it, but on the next title page, I am. So make sure you turn off the spacing, the after spacing, because it makes it look weird. So if you wanted to have this perfect where everything looks nice and neat and all pressed together, if you have on after spacing, you're going to get some weird spaces, awkward spaces. So if you look at it, go into paragraph, and turn on 6, so that's the average one, you'll notice not only does it kick it onto the next page and have a little bit of extra space, that's not enough to be considered double space, so I know what you did. But it's still single space, but you didn't take off after spacing. So if yours looks like this, you have after spacing on. For this paper, I'll take it like this, but keep in mind for your next papers, you need to take it out, so that way it's that nice clean indent, because I know your book's not super clear, but now that I'm explaining it to you, you need to make sure that you learn how to do it for all your future papers. I'm going to go ahead and turn it back off, so that way it pops back up on the front page. The paragraph, oops. So again, gets clean back on this front page. Alright, so 2-inch margins on the top, bottom 1-inch margin on either side. Alright, so you're going to turn in 2 copies of the final draft. Some of you remember from last year that you turn in 1 copy to me, like normal. Then you turn in a 2nd copy, and I'm going to hang on to it for you to the academic fair in the spring. We are believing by faith that hopefully Corona is over and gone by that point, so that way we can actually do our STEM fair. If Corona's still here, we'll worry about it then. But as of right now, we're going to act like we can still do our STEM fair. So you're going to turn in 2 copies. 1 copy for me, 1 copy for the judges for the STEM fair. So I'm going to hang on to it for you until spring. So keep in mind, can the judges know who you are? No. So your title page for the copy for the judges is going to be different. So again, just so you know, for the format and from the bottom of your title page, John Smith, don't actually put John Smith, put your real name. So put your name on here. the date. You might remember that originally I said October 9th would be the date for the final project. Because it's in the middle of, because that's toward the end of exams and we don't want to overwhelm you, we're going to kick it back another weekend. So, yay, you have a whole other weekend now. Just keep in mind the date's been moved to October 12th. So you have an extra weekend, so that's nice. But make sure that you are working on it. So, Miss Morris, this of course is physical science. So I'll go ahead and just change that down here. I didn't change it from life science yet. So, physical science. Now you'll notice that it's supposed to be in all caps, so I'm going to go ahead and fix that really quick. Go to margins. Go into, nope, that's font size. Uppercase. There, that'll fix that. Alright, so just make a note though, physical science class, Miss Morse. Like I told my junior hires, I'm still Miss Morse. So if you want to put Ms. Morse, that's fine, or Miss Morse, either one is okay. I'm not married, probably won't be married in the next couple of months. So, Miss Morse is fine, gotta turn on capitalization. Miss Morse is fine, Ms. Morse is fine, either one is fine. Not Mrs. Morse, don't put Mrs. Morse. It depresses me whenever people do that because I'm not married and I'm not married yet. So, October 12th, make a note for that though, as the date for it. So, going back to taking out your name. So, I do need your name on one copy of it. The other copy I don't. Well, if you just get rid of it, and you just delete it, you're going to jump up out of that 2-inch margin. So, how do you make sure that you're still at the 2-inch margins? So, again, back to the spacing. Put this back in the center. You press space, space. I accidentally deleted 2 minutes by accident. Space, space, space. Whoops. Now it's gone over. Go back one. Yep, okay, so that pushes you to that 2-inch margin. So you're going to have to play with it a little bit to make sure that you're right there at the 2-inch margin for it. So don't just delete your name and think, oh, I'm done. Nope, you still want this second page to be right there at the 2-inch margin, so be careful. I'm going to go ahead and put the name back in. Put it back at the 2-inch margin, because apparently it must have moved when I was playing around with something. Okay, so I'll put it back to the 2-inch margin. So 2-inch margin. Make sure for the copy for me to grade you have your name, because since it's typed, I can't go off penmanship anymore. Now typically I can tell by what the paper's about that, oh, I know who this is, but I don't want to do that. So have your name, so I know who's this who's clearly, but the second copy should be the exact same. The only thing different is it should not have your name on it. Do keep in mind as well that everything on this title page is capitalized. Everyone should have background as the title. Don't put STEM project, don't put science investigation, don't put magnetism, whatever your topic actually is. Just put background. We're all going to be the same. So, background, all caps. Bottom part, all caps. Single space. Keep in mind, for this one, I'll let you have the after spacing, but for future ones, you need to be able to fix that. So I know it's a little bit hard if you haven't had computer apps yet. So if you want to get it perfect, go ahead and take it off, so you don't have to worry about it anymore. Okay, I think that is everything for this. So I believe that's everything. Talked about format, talked about the requirements, 3 to 6 paragraphs, third person, Times New Roman, double space, ½ inch indent, 3 paragraphs, 3 paragraphs, 350 words, 14 to 18 point font, 2 copies of the final draft, 1 copy has your name, 1 copy doesn't. Alright, so make sure, if you have any questions about it, be sure to email me, so that way I can help you out for it. So make sure, also keep in mind that your parents need to email a copy of this background paper. They can either take a photo of it if they printed it out for you already, or they can just send me an attachment of the background paper. I just need to make sure that you've already worked on it. Remember, this is part of your STEM project responsibility grade, so I need to get a copy of this. So if you want to work on it a little bit after class and fix it, that's okay. But make sure that your parents send me a picture of your updated background paper. So they can either just send it in just a straight email, that's fine. If they printed it already, they can take a photo of the printed copy and send it to me as well. Either way works, but I need some type of verification that you have worked on it and you do have your background paper. Alright, you can go ahead and put that away. Alright, your classwork, we're going to kind of jump into it, working on that last problem on page number 105. I talked about this yesterday. Make sure you're going over your terms and definitions. So thinking back over, we've covered a bunch of them. So make sure that you're still covering them. So use your time to review and to go over them. So make sure that you're focusing on that. let's go ahead and start on page 105, that application number 4, that's where we left off yesterday. This is a good practice problem for covering a bunch of different things. Alright, so number 4, how much heat is released by cooling 1,000 grams of water from 130 degrees Celsius to negative 15 degrees Celsius? And it says, hint, use the table of specific heats on page 82, consider what state water will be in at different temperatures. Alright, so it's kind of giving you a heads up. Your book has already told you in those pages that you're going to have to use the different charts to figure this out. This is like a master problem to check a whole bunch of things at once. If you remember yesterday, I said that it is checking 5 different things at once because at a 100 degrees, I'm going to shift over a little bit. Yeah, I can zoom out. Nope, that zoom in. Okay, so I can be in it at the same time. That works. Alright, so whenever you were talking about at 130 degrees Celsius for water, will water exist as liquid water at that point? No, it'll be in that third state of matter, the gaseous state. So it's asking how much heat is released by cooling 1,000 grams of water from 100 degrees Celsius to negative 15 degrees Celsius. What state of matter will water be in whenever I cool it to negative 15 degrees Celsius? Well, this is past 0 degrees Celsius. That means it's going to be solid ice at this point. So it's going from a gas, temperature change, to a liquid, temperature change, to a solid, temperature change. So those are 3 different changes right there because of the 3 different states of matter. But remember, we also have to talk about latent heat. What's latent heat? Alright, latent heat, remember, is the amount of heat because there's no obvious temperature change. The latent heat appears hidden. So it's being used to either, if you're adding heat into it, to move the molecules farther apart, or to bring them back together. So we're having 2 state changes from, well, excuse me, 3 technically different states, but 2 state changes. So you're going from a gas to a liquid, so that's condensation, that's one change. And then you're going from a liquid to a solid, or freezing, crystallization if you want to get super technical. So not only do we have the 3 different temperature changes in the states of matter, we also have 2 types of latent heat. So there are 5 parts altogether in this section. So this one is a lot. So let's go through it. Alright, so I'm going to go ahead and slide it over a little bit. So this is the diagram that's showing you, okay, how water is changing over. So I'm going to slide it back over so that way you can see more of the board as I'm getting into it. Alright, how much heat is released by cooling 1,000 grams of water from 130 degrees Celsius to negative 15? And it tells you, so you're going to need the specific heats. Page 82, it tells you previously you need the tables on page 100 and 104 as well for those heats of fusion and heat of vaporization. Alright, so first things first, we have to cool down the steam first. Technically this isn't just water, it's water vapor, or water in its gaseous form. I moved my rack, so that's what I moved away from. Honestly, I'm doing, I can clean up my board. I'm gonna need a lot of writing. Oh, found it. 1803. Hopefully you remember, this is from U.S. history class, but hopefully you remember what happened in 1803. Louisiana Purchase, but that's not important right now. Unless you're Brecken, because Brecken's in both classes. So hopefully Brecken, you remember, this is 1803, Louisiana Purchase. Alright, so getting into it with this. Alright, first things first, we have to change the temperature of steam. Now, if we're looking at temperature change, and it tells you if you're going to have to use specific heats as well, what equation can I use if I'm using temperature change, mass of an object, specific heat, and I need to find heat in general? Alright, you should hopefully recognize, okay, I have this equation, but I can just shift this one and move this around so that way I can find heat. So moving this one, it becomes Cm delta T becomes Q. Remember, Q stands for heat. So again, we're applying a lot of things in this. So that's what I need to find. Alright, so it tells me what is the specific heat for steam. So it's not the 4.18 or 4.16, it's 4.18. You have to look on page 82 what's the specific heat of steam in particular. So if you flip over there, I'll flip with you. So if you flip over to page 82, you'll notice, okay, gotta find steam. Going down, going down, going down. Okay, so the third one from the bottom, steam is 2.08. That's specific heat of steam. Alright, so specific heat of steam, 2.08 joules per gram degree Celsius. I'm probably not gonna write my units over and over and over again in the side note because we're gonna be doing this a lot. The big note for the units for specific heat, joules per gram degrees Celsius. The mass, I have 1,000 with a decimal point, so that's 466 grams. And then the temperature change. If I'm going from 130, don't just think it's 130 to negative 15. I have to be able to go to the point whenever the steam condenses into water. At what temperature does steam turn into water? Liquid water. 100 degrees Celsius. So what's the difference between 130 and 100? I almost said it by accident. 30 degrees. So 30 degrees. Technically, it should be negative 30 because the temperature is going down. We'll talk about how to fix that later on, but for right now, we'll just leave it at negative 30 because the temperature is dropping. So technically, heat's being lost. We'll talk about how to fix it to get rid of this negative number later on because I don't want to work with negative numbers the whole time. So I'd rather work with positive and just change it at the end saying that, hey, the heat's being lost, so it's negative. So we'll talk about the reason why, how to fix it later on. Just right now, leave it as negative 30. I think the bar's in the way. No, I think you can still see it. Don't know really how to fix that, so I'm going to shift this down just a little bit. Don't fall, computer. Trying to see if that makes it better, unless that makes it worse. Going to shift it over a little bit more. Now it's just weird. Probably should go up to where it was. Okay, we'll leave it there. I think that's... Nope. I move around too much. That's my problem. Don't follow me. Okay, we'll leave it there. Actually, no, just remember not to move. Okay, that'll help me to remember where the pole's at. Okay. So, how do I solve for this? So, multiply all this together. What do I get? So, I'm going to type it in as 2.08 times 1,000 times negative 30. Hopefully, you punched it into your calculator by this point. So, that is negative 62,400. Remember, joules for the energy or for heat. Now, I'm going to write this off to the side. Now, since it's asking what's the total heat lost, I can go ahead and say negative Q, or the heat equals this, because this is all the heat lost altogether. So that way I can just forget about the negative numbers. I'm going to have to add all this amount of heat lost altogether up later on, and I don't want to remember to make them all the same sign. So I'm just going to say here's the total heat lost for so far. Then it has to lose 62,400. But it's technically a negative number because it's being lost. So we're just going to leave it off right now, and I'll just remember to apply it at the end. So for step 1, so I don't forget about it, 62,400 joules. So that's how much in this first step. All right, second step, I have to condense my water from steam into liquid water. So what's the equation we use, or what chart do we use? 104 or the one on 100? If we're going from a gas to a solid, gas to a liquid. Alright, it's the heat of vaporization. Technically, if you're going down, it's heat of condensation. I looked it up just to make a double check for it. Technically, if you want to get super technical, that's the name for it at that point. But since it's the same value, either direction, scientists understand that, okay, if you're calling it the heat of vaporization, it's also understood that it's the heat of condensation if you're going back the other direction. So we just call it the heat of vaporization just so that way it's an easier term for it. Alright, so I have to basically condense and figure out how much energy does it have to lose to go from a gas into the liquid version. Alright, so let's look at the chart on page 100. You have to figure out how much heat does it lose. You notice it loses a lot of heat. It'll have to lose 2,260 joules of heat for every gram. So joules per gram is the heat of vaporization. So 2,260, how many grams of steam do I have? Right, 1,000. So as you can tell, this is going to be a really big number. Multiply these two numbers together, and that'll give me my answer. Alright, so for this one, it's 2,260,000 joules. So again, I'm going to write this up here. So part 2, 2,260,000 joules is how much heat is being lost. Keep in mind, all this is still negative. I'm just not putting the signs up there. Alright, so that's to go from a gas just into the liquid stage. Alright, next I'm going to change the temperature of my water. I have to go from 100 degrees all the way down to 0 degrees. So what's that temperature? So what equation should I use? Good job. Specific heat again. Alright, my temperature change is negative 100 because I'm dropping from 100 to 0 degrees. The mass is still 1,000. If you don't remember what the specific heat of water is now, you can go look it up. You might remember it is 4.18 joules per gram degree Celsius. It's a really bad J. Alright, so you multiply all these together, and that will tell you how much heat you have to be lost for it to drop that much of a temperature change. Whew, I'm running out of air. I'm talking too quickly. Hyperventilating. Alright, so for this one, the total comes out to negative 418 joules. Alright, so again, because this one the temperature change is negative, that's why it shows the negative. I'm just going to remember all of these are basically negative. It just doesn't show up in the equation. I'm going to remember it and just make sure that they're all negative at the end. Alright, I'm going to copy this one down. So 418, yeah, that works, joules for that one. And step number 4 now, because I'm not done. I have to go from a from a liquid to a solid. So remember, what do I use, or what chart do I use if I'm going from a liquid to a solid? It's the chart on page 100, good. It's the heat of vaporization. Technically, since we're going from a liquid to a solid, it's heat of crystallization. Double checked it again. But scientists understand, okay, it's the same amount. It just depends on what direction you're going. So heat of vaporization, a lot of scientists just call it that as just an easy reference point. Alright, so we have to go from a liquid into ice. So you want to see what's that heat of vaporization? So that is 334 joules per gram for the heat of vaporization for water. How much water do we still have? Right, 1,000 grams still. So for this one, you multiply these two numbers together, and you get, oh, it's right where the bar is, let me write it over. 334,000 joules. I'm going to top this up. Oh, it's kind of like a 9. I'm going to fix it. So that's step 4. We're getting there. Alright, step number 5. Last step. Finally. I have to have that last temperature change. So I'm going not to 0 degrees Celsius, negative 15 degrees Celsius. So if I'm going from 0 to negative 15, what's that temperature change? Right? Negative 15. What is the mass of the water? I keep saying water because that's the substance that it is. Technically, it's ice at this point. So, 1,000 grams. What specific heat of ice, though? Remember, steam was different from just liquid water. So, ice also has a different specific heat. So, go back to page 82. Figure out what the specific heat of ice is. Too far for me. Alright, you find ice. It's around the middle-ish, so it's 2.06. So 2.06 joules per gram degree Celsius. Whew. That was 2, looks like a 7. Alright, multiply all these numbers together. You're going to get, for this one, negative 30,900 joules. So again, since all these numbers are technically negative, I'm going to just drop the negative sign. So for step 5, it is, I lost my spot, 30,900 joules. Okay, so now it's asking what's the total heat loss. So now we're going to add all of these up together. Which be very careful with your calculator that you type them all in correctly for it to make sure you get that proper amount all the way through it. Alright, so for this one, your final answer turns into 3,105,300 joules. So 3,105,300 joules. Technically it should be negative because that's how much you've lost. Or you can say, hey, I've lost, and it's understood. Now keep in mind for sig figs, how would you solve this? Technically, our last step was addition and subtraction. So sometimes people will say, oh, because there's multiplication, we should round it based on multiplication and take those sig figs. And then sometimes, because the last step was addition and subtraction, we should base it off that. Personally, I go off the last step, because if you start rounding in the middle, you're gonna potentially mess up your numbers, and I like to be safe and sorry to make sure I round only at the end. So because of that, if you look at what you're given, if you look at the placement of it, 1,000 ends in the hundredths spot, 130 degrees Celsius and 50 degrees Celsius, all of those end in the hundredth spot. So I would say, if you put your decimal point here, that would be an acceptable answer, as okay, you rounded based on addition, so because of that, that's a fine answer. But if you want to go up multiplication and division, which sometimes people say that, so we'll go talk through that one as well. So because your first number has 4 sig figs, the third number, the 130 degrees Celsius on how it's given, that's 3 sig figs. 50 degrees Celsius, that's 2 sig figs. Sometimes sometimes people will say, okay, this one has 2 sig figs and you multiplied, your answer should also have 2 sig figs. Well, how do you get 2 sig figs in something like this? You just drop the others and just leave it as 3,100,000, no decimal point. So sometimes you'll run across people that say this answer also works for it because you rounded multiplication. For me and for my class, if you round at the very end, I consider that's fine, and that's how I personally like to do it. So I say this is a good final answer because you were going off addition and subtraction, and so since it ended in the one spot, I will say it also works for ending it in the one spot. Alright, so we'll go ahead and we'll stop there actually, because I know that took a while. That was a lot of math, but that was a good way to review and go over a lot of the math concepts and a lot of what we've been practicing with over the past couple of days. I know this problem was a little bit of a doozy. So make sure that your parents email me the photo or the copy of the background paper. Be sure to email me if you have any questions about it. Alright, your homework for tonight is you're going to just give just a little bit. You're going to, let me get to the right spot. You're going to read pages 108, that's it. Read page 108 and then answer on page 110, question number 8. So you're going to read page 108 and then answer on page 110, question number 8. Study your terms and definitions. I didn't give you a whole lot of time or classwork for that in class, so I'm a little bit early, so make sure if you didn't finish the background paper, the second draft, work on that and email it to me. And then also study your terms and definitions. So I said a lot of them, but make sure that you are